Alright, so we're going to talk for a second about second derivatives, what they are and how we can find them. So let's say we have some function, and we'll call it f of x. Alright, now this f of x could be x, it could be x squared, it could be x squared plus 5, it doesn't really matter what it is. We're just going to talk about some function. Now let's say this function has a derivative. The derivative is going to be shown as f prime of x. That's just how we show the derivative. It's the same thing as saying d dx. You know, the derivative of f of x is f prime of x. So that's just our normal first derivative that hopefully we already know how to find. Now what we're going to talk about is something called the second derivative, and that's going to be f double prime of x. And this second derivative is just the derivative of the first derivative. So you derive once, you derive twice, and you get f double prime of x. Alright, so we can better understand first and second derivatives with the analogy of water. So let's say we start with a block of ice. Let's just pretend that that actually looks like a block of ice. This is going to represent our f of x, our original function. This is what's normally going to be given to us. You can think of it as solid. We know what it is. Now what we're going to do is heat up the block of ice, and when that happens we get water, and we'll pretend that that actually looks like waves. So we get liquid water here. All we did was heat it up. That's going to be, this heating is going to be an analogy for taking the derivative. And then f prime of x, our first derivative, is going to be, the analogy for that is the liquid water. Now what we're going to do is heat it up again, and you get steam, the gas form of water. So there's three things we can learn from this analogy. The first is that all three of these things, just like all three of these things, are related. They're not exactly the same thing, but they depend on each other. The next thing we can learn is that just like here, we're doing the exact same thing, whether we're heating it up on a stove or by the sun, whatever. This is getting heated the same way. They're both getting heat. Just like here, where you take a derivative, and then you do the exact same thing here. You just take the derivative of f prime of x to get f double prime of x. And the last thing is that just like you can't skip from ice to steam unless you have a special setup, you can't skip from the first, or from the function to the second derivative without going through the first derivative. You have to find the derivative and then find the derivative of that to get your second derivative. Let's say that our f of x 1/3 x cubed plus 5/2 x squared minus 7x. Okay, in that case, we know how to find a derivative. The derivative of f of x, f prime of x, is equal to x squared plus 5x minus 7. And now to find the second derivative, you know how we found a normal derivative, we just do the same exact thing. F double prime of x, you just find the derivative of this function right here. The derivative of x squared is 2x, the derivative of 5x is 5, and the derivative of negative 7 is 0. So we have now our second derivative. So our second derivative of f of x is 2x plus 5. And it's that easy, that's how you do it. Why do we want to learn this? I mean, it's just, you know, it seems like some random thing. But actually second derivatives are really useful for finding lots of different things about a function. The first thing it can tell us is a relationship between the first derivative and the second derivative. I'm going to write that down. F double prime of x is positive. F prime of x has a positive slope. So just like when f prime of x is positive, f of x has a positive slope. Same thing applies here. And then it goes the same thing for negative. When f double prime of x is negative, f prime of x has a negative slope.